Okay guys, today we're going to start a new unit in transformations. And transformations is an important concept in geometry. And it takes the original shape, figure, whatever, and creates a new figure from the original through 4 different things. And these 3 are called congruency transformations. Okay, and this one is a similarity transformation. And so for this unit, we're only going to talk about our congruency transformations. So when you translate, you're going to either slide up and down on the x-axis, or side to side or up and down. If you're a reflection, that's where you're kind of like jumping over the axes, kind of like at the mirror. And the rotation is where you're either turning counterclockwise or clockwise. Alright? When you do the dilation, that's basically where you get either bigger or smaller depending on your ratio. And we see a lot of transformations in artwork and tessellations, which is a repeated pattern with no overlaps. And I will give you a bonus point if you bring me either a picture of a tessellation, you can find them all over the place, or the name of the artist most famous for doing tessellation work. Either one will get you a bonus point. Alright, so we have some transformation vocabulary that we've got to talk about. The image is the figure after the transformation, okay? And then the pre-image is your original figure. Pre meaning before, and so it's before the transformation. Your notation for your pre-image is like you just have your ABC. But for the resulting image, you would say A becomes A prime, and B becomes B prime, and then C becomes C prime. All right? Isometry is a transformation where the distance between any 2 points does not change. And so if I have a line segment here, I've got 2 points, and I'm going to slide it over, so I'm translating it, okay? The distance between the points did not change whatsoever, right? They stayed exactly the same. So that would be an example of an isometry. The rigid motion is where you have an actual motion. So isometry has to do with the distance of the points, and so the length, and the rigid motion has to do with the actual motion, like when it's flipping over the figure, but everything still stays rigid or the same. All right? Okay, so let's talk about our notations a little bit. Translations are denoted with a capital T. And there are 2 different ways you can put it. You can either say xy is going to go x plus whatever number you're translating, and whatever number y is translating, or you can just put it as the number x and y down below. It's kind of confusing, but let's go through and kind of take a look at it and see what it has to say. So what we're going to do is we're going to write the rule for the translation, and we move in the direction for the axis. So that means if I'm moving this way, I'm positive. If I'm moving that way, I'm negative for my x's. And if I'm going up, it's positive. And if I'm going down, it's negative for my y values. Okay? So let's find the rule. So for A to go to A prime, we need to look at what our x and y does. So I start at my A, and I'm going to go over 2, 3, 4, 5. So my x went a -5, and then it went up 2, so +2 for the y. Okay? Now, if I look at my b prime, I'm going to go over 2, 3, 4, 5, so -5, and then up 2, +2 as well. And so I'm guessing that my c prime is going to go over to the left 4, 5, and up 2, which it does. And so the translations are that I'm going to move left or -5 and then up positively 2. So let's rewrite that in both different ways. So I'm going to translate where x moves 5 to the left and y goes up 2 for triangle ABC. That's one way you could write it, okay? The other way you could write it is just to saying I'm going to translate -5, 2 for triangle ABC. Okay? Either way, doesn't matter. Both works. This looks more like an ordered pair, but you got to remember that's the actual movement. All right, so let's do another example here. So we're going to graph and label our figure. So W is up over 2, up 1. X is over 5 and up 1. Z is over 5 and down 2. And Y is down 2. All right, so thinking about what we just, whoops, I went down too far on that one. Thinking what we just went through on the coordinate plane last unit for what kind of quadrilateral is that? Well, I have straight line, 0 and undefined lines, so that means that I have perpendicular lines. And if I have perpendicular lines, that means I have right angles. And if I count the distance, I have 2 on both sides. So 2 is congruent to 2, and I have 1, 2, 3, 1, 2, 3. So I have 2 congruent sides, and so that makes it a rectangle by the properties. Okay, little sidetrack. Let's go back to translating. We're going to translate the unit 5 units up, left, and 2 units, or 5 units left, 2 units up. So I would say I'm going to translate either -5, 2 for W, X, Y, Z, or I could write it as X minus 5, Y plus 2, W, X, Y, Z. All right, and so now all you do is do your counting. So 1, 2, 3, 4, 5, up 2, and that becomes W prime. Okay, now let's go and do again. 1, 2, 3, 4, 5, up 2, and that becomes X prime. And then 1, 2, 3, 4, 5, 1, 2 is Y prime. That's going to be Z prime, and there's my translated. Okay. All right. Now, for the second one here, we're just going to look at, we're going to start at this second one here where we ended. This is kind of confusing. We're going to end at the second one where I am at -3 and 2 for W prime, and then X is at 0, 2, and then I have Y prime and Z prime. Okay. I think I went up, I didn't go up one enough, but this is good enough. So W prime we're going to have as -3, 2, and X prime is going to be 0, 2, Y prime is going to be negative 3, 0, and z prime is going to be 0, 0. Okay, the second thing we can do is, let's say we now want to do a translation of, let's say we're going to add 3 to the x and move it down 6. All right? X, Y, Z. Okay, so if I start at the W prime, that means now I'm going to go to a W double prime. All right? And another method you can do is, if you have the ordered pair, is just add it to your coordinates. So if I have negative 3 and 2, and I'm going to add x plus 3 and y minus 6, that means that W prime is going to end up being an ordered pair of 0, negative 4. So let's go to 0, then down to 3, 4, and that's W double prime. And let's check, see if my math was right. So did I go, oh wait a minute, I have x, yeah, 1, 2, 3, 4, I just did the math wrong, didn't I? W prime, because I went plus 2, 3, down 2, 3, 4, W prime. Sorry about that, because I am at 2. All right, and then you just 1, 2, 3, 4, and 4. And so you can either do the addition or you can do the count. If you have the graph, it's just as easy to count, but either way works. All right, so our translations, isometries, well, let's think about what that definition is. An isometry was the distance or length between the 2 points does not change. Did I have a length of 2 here? Yes. Did I have a length of 2 afterwards? Yes. Did I have a length of 2 here? Did I still have a length of 2 after I translated? Yes. So that means that they are isometries. Are they rigid motions? Well, let's think about what a rigid motion is. A motion, but it contains the figure and the size shape is rigid or the same. So did we change anything about the shape? No. So that makes them rigid motions. Do you think all translations are rigid motions? Because if you think about it, you're just taking the image and you're just sliding it over. So that makes, yes, they're all rigid motions and they are all isometries. Okay? All right, last one. Let's do the rule for the translation. So I'm starting at A, and my point here was 2, 2, and I went to A prime, which was 1, 2, 3, 4, 5, 6, 7, 8. So x minus 8, and then 1, 2, 3, 4, 5, 6, 7, y minus 7. Now, I can go through and check each of these again to make sure I counted everything right and to double check my work, and I got the same. And do one more just to double check and make sure I didn't make any mistake on my graph, and I'm good. And that is translations.